Now, today this video is a shortcut to solve for sine function, cosine function, and the tangent function. Now, how about if we're talking about the cosecant function and the secant function and the cotangent function? When you are talking about those functions, you use the same idea of what we are going to talk about today, but remember, it's just the if we say inverse function, kind of confusing, right? 1 over cosine function, the reciprocal function. Now, when we talk about inverse function, it's not something like the inverse of 3 is 1/3. That's for number. So this is reciprocal. Okay, anyway. So right now, when we talk about inverse function, it's not a reciprocal. So it means we are not going to talk about the reciprocal function for sine, cosine, tangent. No, we are not talking about this. But if you want to deal with this type of the reciprocal function, you just make a reciprocal. Then you can use the same idea what we are going to learn from today. So let me erase this. So today we are not going to focus on the reciprocal function. Now the inverse function we are talking about here, the inverse function is this input. Sorry. Input, output. This is output. And the inverse function will exchange input and output for a new function for the inverse function. So we use this notation to talk about the inverse function. Now for the inverse function, our input become y and the output will be x. But before we can make a inverse function, basically we don't want to write down y, we still want to write down x. So we will say exchange x and y. Okay, so when you are talking about inverse function, actually the input was the output from the sine function, but we still write down x, y. Okay, so this x is this y. This y is this x. We learned that from algebra 2, so I'm not going to spend too much time talking about how to exchange x and y and so for the inverse function. Okay. So this one thing, before we start today's video, we shortly talk about the inverse function for sine, cosine, tangent. We use this notation. Okay. And how we read, we can read as inverse function, inverse sine function, or we read arc sine of x. I said that this x was y before, okay? And equals to y. This y was x before. So when we exchange x and y, then we have inverse function. Now inverse function is not a reciprocal. So that's one thing before we start the video. And the second thing we want to talk about actually for today is we want to solve for the equation, or you want to solve for the function. When I give you y, can you find the x? So in other words, x equal to what? When you have sine function, cosine function, and the tangent function, can you solve for x? Solve for x. Now, let me give you an example first. How to solve for x? For example, if I have a very easy question, sine x equals to 0. Looks like a very easy question, right? So we make a unit circle. And where is the sine function? So we say this is if, oh, okay. So if this unit circle means the radius is 1. Okay. Radius is 1. And for any angle, this opposite over hypotenuse, and the hypotenuse is 1, so the opposite will be sine value, sine theta. So when you have a dense here means the sine theta not equal to 0. So where you have sine theta equals to 0 is here. When you have, make it too big. Okay. It's hard to erase. Okay, here. Okay, so when you have this triangle, the height is lower down and lower down till the height of the triangle is 0. Here, when height is 0 means we no longer can make a triangle. So when angle equals to 0 happen to be sine 0 equals to 0. So if I ask you to solve for x, can you say x equals to 0? Yes, you can say x equals to 0. But can I say x equals to pi here? Yes, you cannot make a triangle, right? So means the height is 0. And can you say the answer is 2 pi? So angle 2 pi will come back. The period of sine, cosine are 2 pi. Are 2 pi. Therefore, when you go back to 2 pi, you almost go back to, actually you go back to the same angle, just the number is bigger. We call this 2 pi and the 0, they are coterminal. Coterminal angles. Okay. So we are going to talk about review the coterminal angles. Is very important here. Why? Because when you solve for x, you have more than one answer. You can guess one answer, or you can use calculator. How you use a calculator, we are going to talk about that. Okay? So before I can provide a shortcut, you need to have some idea of how your answer will look like. So your answer, if you find the if you are able to find at least one answer, so I already showed you, you have more than one solutions. So if you find one answer, you need to consider more answers from coterminal angles. So if you say x equals to some angle, we say 30 degree. Oh, no, we are talking about angle 0, okay? Then plus minus 2 n pi. N is 0, 1, 2, 3, keep going, okay? We don't include 0, okay? 1, 2, 3. And you plus minus 2n pi. N supposed to be, yeah, we consider n is 0. We need to consider n is 0. 0, 1, 2, 3. So when n is 0, you just don't plus anything here. But when n is 1, you plus 2 pi, 4 pi, 6 pi. So you consider all the coterminal angle are the answers. So we are going to talk more detail later. But first, you need to understand. You find one answer, and then you're supposed to provide a stream of the answers plus 2n pi. And also, we mentioned x may be equal to pi, and then you plus minus 2n pi. So you may find two groups of solutions. Two groups of solutions. Very important. Now, when you go to tangent, it's a little bit special. We may combine these two groups become one group. We are able to do that. So it looks like only one group. We can combine two groups become one group of the solution. But initially, you need to have two groups of solution. You need to be able to find two groups of solution for all the sine function, cosine function, and the tangent function. Okay. So this first part we want to talk about. Your answer need to include all the terminal angles and the two groups. How you find two groups? I will say two all the coterminal angles. Sorry, not the terminal angle. Coterminal angles. Coterminal angles. Let me show you the coterminal angles. It's easy to understand. We learned that before. Okay. So, for example, if I change the number to 60, 60, and then plus 360, 2 pi, right? 60 plus 360, which is 2 pi. 60 means pi over 3. So this pi over 3 plus 2 pi, which is 420. So this is 420 degree. And pi over 3 plus 4 pi will be 60 degree plus 720 degree, which is 780 degree. So I change it to 780 degree. So if I change it to the easier number of the degree, you can easily find the sine 60 is square root of 3 over 2. Therefore, sine 420 still same thing. And because they are the same angle, okay? They are the same angle. The degree number looks so big, but because they are coterminal angles, coterminal angles will result in the same sine value or same cosine value, okay, same tangent value. So some students say, okay, I can see that in the formula we can use arc sine square root of 3/2 equals to 60. Yes, okay. But can we say arc sine square root of 3/2 equals to 420? Then we say no. And can I say arc sine of square root of 3/2 equals to 720 degrees? I will say no. So this no, oh sorry. We use this degree to answer our arc sine function, but we don't use those degrees. Okay? Why is that? Let me show you why. So we need to go back to our first page. Since by the definition, inverse functions are functions. Remember the definition of functions. One input corresponds to exactly one output. So if I ask you to solve for the previous equation, I say, can we solve for so we understand more than one angle input to the sine function. We can have same value, square root of 3/2. Now, how many solutions? Sine x equals to square root of 3/2. So for x, so you can, at least you can say 60 degrees, 420 degrees, 780 degrees. And you understand it's more, so we say 60 plus minus 2m. We cannot say pi. Okay, let me change it to pi over, we use radian. So I will say x is pi over 3 plus minus 2m pi. I think everyone should agree right now. If you don't agree, means you not quite understand yet. That's fine. You can go back to start the video again and watch the video from the beginning. And if you still have question, you can ask me question on the office hour. But I will say this is not the final answer. I will say this is just the first group of solutions. And you need to have second group. Where is the second group of solution? So when you have your pi over 3, you have square root of 3/2. If I say this is 1, then this 3/2, this will be 1/2, if you remember. Okay? 60 degrees, 30 degrees, 1/2 opposite. And the square root of 3/2 and the 1. That's a special triangle. Now, when this is positive, if you go down, it becomes negative. Okay, but we are going to talk about another positive If this is 1, this is negative 1/2 because it's on the negative side. And this is still positive. Okay. So how big this angle is? How big? You will agree this inside is 60. But this we call it reference angle. Reference angle. The reference angle are all pi over 3. Or we say 60 degree. But this angle is not a 60. Obviously, this angle will be from here to here. Okay? So the reference angle are the same. So they have the same sine function on quadrant, sine function value on quadrant 1 and the quadrant 2. And when the sine value are negative, obviously we have the angle from quadrant 3 and the quadrant 4. It will provide negative sine value. Okay. So roughly, I will introduce you how we find the two group of the solution. Number 1, you can use arc sine function. But how we decide the arc sine function? Can you choose 60 degree or you choose a bigger one? This bigger one, how big it is? I will say is pi minus pi over 3. The whole thing is pi. And take away pi over 3. So it will be 2 pi over 3. So you have 2 pi over 3 for another group. So you need to find two group of the angles. These two group angles are not the coterminal angles, but each group you need to write down plus minus 2n pi to have coterminal angle and plus minus 2n pi. So right now, if you feel hard, that's okay. I just roughly introduce the concept of the coterminal angle to you, tell you why our answer need to have 2n pi. Next important things, we are going to talk about the arc sine function. And for the arc cosine, arc tangent function, I will talk more on the next section. Okay, so but the concept for coterminal angle and the concept of the reference angle are the same. Now, because the definition of the function and because inverse function are functions, therefore if you want to work arc sine square root of 3 over 2, you want to choose 60 degree or you want to choose 180 minus 60, which is 120 degree. Okay. On the unit circle, this 300 square root of 3 over 2, this is 60 degree. And another angle is 120 degree. You also have square root of 3 over 2. So if you input the square root of 3 over 2 to arc sine function, you cannot provide the two answers. If you provide the two answers, I will mark you wrong because you didn't get the concept for the definition of the functions. The definition of function is one input, only one output. If you give me two output, That's not a function. And the inverse function, we call it function. So arcsine function is a function. You can only choose one answer. And how we decide you want to choose 60 or 120, not you choose. That's not your choice. The math system, or you want to say our mathematicians, the mathematicians already decide. So you need to memorize. Among 60 and 120, obvious, I want to choose the smaller number. Why you want to choose a bigger number? I think that's pretty obvious. And how about if I input a negative? So negative, you are going to have a negative angle, right? 2 goes to negative square root of 3/2. So if you check with our PowerPoint, I already upload the PowerPoint on Canvas. So this PowerPoint was from our publisher. And you can find the arcsine function we decide all the output is between here. Okay, let me erase all this ugly mark here. Okay. So again, for cosine function, tangent function, I will talk again on the next sections. But here I want to overall tell you the idea and give you a chart for you to easy to understand. So arcsine function or arccosine function will only provide you one group. Okay, this is just one group. And where is the second group? You need to find it by yourself. So this is first first group. And you need to find second group by yourself. So my shortcut is going to tell you how to easily find your second group. Basically, you already kind of already seen how I easily find my second group. Okay, so you need to find the first group and the plus minus 2n pi, and find your second group and the plus minus 2n pi. Then you find your answer. And if you have input is minus, like you input negative square root of 3/2, then you use arcsine function. Arcsine function will provide you one group. And the same thing, that's your job to find second group. So kind of you have idea. Plus minus 2n pi is for sure. And then use arcsine function, you can find one group. And use my shortcut to find second group. Okay. So before I provide you a shortcut, let me tell you I use my own way to show you where are the arcsine or arccosine arctangent function will be defined for your your range. So here, this is for positive input. This is for negative input. That's for sine function, okay? For arc sine function. And then for arc cosine function, here. This is for negative. Here, for positive. Okay? So, you have negative cosine, negative, positive cosine on the first quadrant. And the tangent had the same range. You can see that. The range for tangent and the sine are the same. Positive, negative. Okay? And on the PowerPoint, you can see there's another chart. So that's for your reference. Today, I'm not going to spend too much time on this type of graph. So again, each group you need to plus minus 2n pi for the terminal angles. Now we want to talk about the reference angle. Basically, reference angle can help you easily use the shortcut to find second group answers. And if you use arc sine, arc cosine, arc tangent, then you can easily write down your formula for second group, for the first group, okay? But my shortcut for you here is use reference angle. So I want to quickly talking about what reference angle means. I use theta to represent the reference angle. So let me show you here. So any angle A, what's the reference angle? Reference angle, I think you learned that from chapter 4. But obviously here you can see this is reference angle. And when you go to this quadrant 1, when you go to quadrant 2, this is angle A, but the reference angle is here, okay? And when you go to quadrant 3, this is the angle, but the reference angle is here. So how we decide the reference angle is x-axis and the terminal side. X-axis and the terminal side. The angle between x-axis and the terminal side. No positive, no negative means positive, right? No positive, no negative. It means positive angle. So terminal side, x-axis, this is a reference angle. Terminal side here, x-axis. Between these two are the reference angle. So the reference angle basically are the same in this 4 quadrant. So any angle A, you can find the reference angle. And then we can use this angle to find the shortcut for your second group. So for example, if this is if this was the 60 degree earlier we talked about, then this will be 120 degree because this is 60. So this is 120. And because this is 60 degrees, this will be 180 plus 60 will be 240 degrees, right? And you can say this is negative 60. Negative 60 for this angle A. Or you say, wow, this is a very big angle. So you have 360 take away 60 degrees. So you can also say this is negative 60 or is 300 degrees. Same idea. Okay. Now this angle 240 degrees, you can say is negative. This is positive 120. This is negative 120. So if you have the idea concept of the reference angle, then everything becomes easy. You can easily find out second group. Second group depends on sine function or cosine function or tangent function. They depend on the reference angle. And you can find the second group. Okay? So next video, I will give you all the examples for sine function, cosine function, and the tangent function, and show you how to use all the concept we just learned and use my shortcut to find two group solutions and also find the formulas. Okay, so see you next time for the rest of the document. Bye-bye.